Hello, in this video I'm going to be speaking about an experiment I've done recently with stepper motor voltage and seeing how that affects VFAs or surface quality artifacts on 3D prints. Just to get the results out of the way, if you don't want to watch the whole video, I basically found that it mostly doesn't really matter if you're using 24, 36 or 48 volts. It can have slight improvements on surface quality from using 24 volts in some specific scenarios. But due to the fact that VFAs aren't a single cause issue or a single source issue, it probably won't make that much of a difference. But if you want to see why I'm saying that and the examples of when lowering your voltage or not increasing your voltage might be a good idea, then stick around and we'll go over all of the results. Okay, so just as some background, the printer I've been building for the past few months, the cross gantry machine, I'm just calling it the Dancer Mark 1. At this point it's finished. I've published some other videos on this channel going over the build process for that. And the main quality issue I've been having of the printer is just VFAs. They've come and they've gone. As I've made certain tweaks to the machine, but they generally are the main source. They are the main quality issue currently with my prints. Now, as I mentioned, VFAs, which if you're not familiar, they're basically just repeating vertical, just repeating lines in general on the surface of your prints. They look very similar to ringing. Except they're not, just caused by decelerating, going into corners. They can be caused by all sorts of things, which makes them a bit difficult. You can't necessarily just pin VFAs on one thing, because VFAs aren't really, they're more of a symptom than anything. So they could be caused by a whole host of things, and most likely they're being caused by multiple things all at once. So even if you solve one, that might not fully eliminate VFAs. It might just change the way they behave slightly. And also VFAs, of course you'll have multiple sources for VFAs in your printer, and during different types of movements, different causes will be more dominant than others, as I think we'll see with these results. And the original configuration of this printer is that I'm using NEMA 23 stepper motors, powered 48 volts, and then I just have them set to 2 amps. That's kind of where I'm comfortable running the mats. I don't really need more torque than that. And I just figured, potentially, I just wondered if lowering my motor voltage will have a positive impact on my surface quality, because I already had a extra 24 volt power supply lying around, and then the 36 volt one was just like 25 bucks on Amazon. So I figured, hey, it's pretty easy to just compare these, so might as well. And yeah, so the way I decided to run these tests is I basically just have a few models. I have basically 5 prints. I print 3 times, 1 of each voltage, and I use the exact same G-code file for all of the power supplies. So yeah, literally all I changed between the tests is swapping out the power supply. Everything else stays the same. Motor current stays the same. The G-code stays the same. So it's literally the same. The printer's doing the exact same thing, just with a different motor voltage. And then, yeah, then we just compare the results. So the models that I printed were, first of all, since we're looking at VFAs, a VFA tower. What this is basically just a shape where the printer prints at different angles, at different speeds. So I started this off at 100 millimeters per second, it goes up to 300 millimeters per second. Then the other models were this base mode skull. I chose this because it's just very curvy and kind of has organic shapes, which I found causes the worst VFAs on my machine. Then just a benchy, because it's a benchy. Then a voron cube, because it's just a bit more, has a few more corners than these other models. And then just like this tray, because it's just got lots of long straight sides where you know, the printer will be moving at speed for a longer distance. Yeah. And then as well as looking at VFAs, I also wanted to see if there's any difference in the noise that the motors makes, because something that's quite annoying about this printer is how loud it is. Not just from like the part cooling and stuff like that, that's actually not too bad. Just the whir and the hum of the motors is just very loud. And I was hoping that maybe by dropping my voltage, it'll be a bit quieter. I didn't really notice any changes in motor volume, just the specific pitch and the tone was different, but the volume wasn't really that different. I'll play some clips now, just comparing each of the voltages. Yeah, so as you can maybe hear, there's differences in pitch, but not really in volume. It's not going to be noticeably quieter to run 24 volts instead of 48. Yeah. Anyway, getting into the results. So if we look at all of the prints, they all have VFAs. You know, dropping from 48 to 24 volts didn't just make them disappear, sadly. That would have been nice. But, and you really can't, I couldn't tell much of a difference between each of these prints. Like on the skull, for example, you can't tell any difference. It has really the same amount of VFAs for each of the voltages. I've looked at these for quite a while under the light, and I cannot tell which one's which. You know, I think I convinced myself initially that I could see a difference, but that's just cope. I can't tell. I can't tell any difference between the VFAs for these skulls, or in fact for the benchy or the voron cube as well. Yeah, I just can't tell any difference. No matter what angle I look at, there's just no difference in surface quality between the voltages. For the voron cube, I can kind of tell a difference in some regions, because this is all these walls are in line with either the X or Y axis. There's no like really angled walls. The VFAs are just kind of lower anyway, and I just can't tell the difference. But the interesting thing comes from the actual VFA test towers. So when looking at these, you actually can start to see where there are differences between the voltages. So if you look at them from the top, they have 90 and 0 degrees. So these basically just are in line with your axes. So it's just one axis moving at a time for these two sections. And then for the rest, they're all angles, like 45 degrees, 60 degrees, and 30 degrees. So for all of the angles that aren't straight in line with your axes, you can't tell really much any difference with the amount of VFAs you're seeing. But for the 0 and 90 degrees, you can. It's subtle. It doesn't really come across too well over camera, But if you directly compare the 90 and 0 degree walls for the VFA tests between 24, 36, and 48 volts, you can tell there is a actual improvement in surface finish between the voltages, 48 volt being the worst, 24 volt being the best, and 36 just kind of being in the middle. This is just because I think that, like I mentioned earlier, there's multiple sources for VFAs, and depending on what type of movement your printer's doing, different causes, you know, are more or less dominant. So let's just say when you're going 45 degrees, the dominant cause for VFAs is, you know, the belts interfacing with idlers and pulleys. But then once you get to just the right angles, 0 and 90, the dominant cause of VFAs are motor-induced VFAs, which means that you know, the balance has shifted, and now the lowered voltage actually does have a noticeable impact on surface quality. Any improvements, any changes to the motors that would, you know, decrease VFAs on the right angles just weren't dominant enough of a factor to decrease VFAs on the 45 and the 30 degree angles. This is also quite visible on these trays that were printed. When you compare all of these side by side, again, it doesn't come up too well on camera, but it is clearly visible, is that 48 volt has the worst, 24 the best, and 36 somewhere in the middle. Again, this is because I think just for these straight lines directly along the axis, the dominant cause of VFAs are motor-induced VFAs, and those just are reduced when you have less power going through the motors. Yeah, so I was a little disappointed by all these results. I mean, I was kind of hoping it would just be some, you know, magical switch that would just give me really great surface quality if I just lowered my voltage, but it didn't really do that. And frankly, the small changes in surface quality, like the small surface quality improvements for straight walls that are observable here, I don't think are justification alone to make the switch. Because ultimately, if you switch from 48 to 24, you're going to be going slower, your accelerations aren't going to be as great. Yeah. So that's that. I mean, I'm a little disappointed, but I think I'm glad I tested this out just so I know. I think I am gonna still stick to 24 volts, just because, you know, I don't need my machine to be going very fast. I'm only gonna be printing with, you know, my standard slicer profiles, which, you know, aren't that crazy. I think travel accelerations are like 25k. So it's not that crazy, and you know, if it draws less power, and you know, the motors don't get quite as hot, I think that's fine. I'll take the marginal improvements for some prints. Though, if I cared about going really fast and printing really fast, I wouldn't make the switch. The quality improvements just aren't big enough to really justify it. But since speed isn't really my priority, I think I'll just stick with 24 volts anyway. Yeah. And I'd like to say, this is only with, you know, this might not apply to your machine. The balance of what causes VFAs on your 3D printer will probably be very different to mine. So the degree to which something like switching motor voltage will improve your print quality will differ from me. But maybe this is just something you can take into consideration if it's something you've been thinking about. Anyway, I hope you can find this interesting. I certainly am glad I've looked into this because now I know. Anyway, thank you for watching. Consider liking and subscribing.